Okay, so for today's video, we're going to look at triangle similarity. And we're actually going to focus on 3 similarity theorems that can prove if 2 triangles are similar. We're going to do 2 examples of each: angle, angle, side, 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 and side, angle, side. So let's first review what similar figures are. Okay, so our definition of similarity: 2 figures are similar, and there is our similar sign, if their angles are what? If their angles are congruent. So we have the same angles. Fix my pen here. There we go. Congruent, and their sides are proportional. Proportional. Okay, so same angles, but proportional sides make us the same shape, but different size. So here's an example again of 2 similar triangles. You can see that all 3 of our angles are congruent. So A is congruent to E, B to F, and D to G. All right, so angles are congruent and our sides are proportional, and we can check that by seeing if we have the same scale factor, right? So 4 times 7 is 28, 6 times 7 is 42, and 5 times 7 is 35. So all the sides were multiplied by the same number, which makes them proportional. Okay? Now, we don't always have to have all 3 angles and all 3 sides to prove similarity, and that's what these theorems are going to show us. Okay? We actually have certain circumstances where we only have to have some of the information. So those 3 theorems are here. First is angle, angle. All right? So angle, angle theorem says 2 triangles are similar when any 2 sets of corresponding angles are congruent. Corresponding means that they match up. Right? So here's an example of angle, angle. We have 2 triangles here, and we have angle B is congruent to angle Z. So we have one set of corresponding angles that are congruent. And then angle A is congruent to angle Y. So we have 2 sets of corresponding angles that are congruent. All right? Because all triangles have to add up to 180 degrees between their 3 angles, if we can show that 2 angles are congruent, the third one has to be congruent in order to add up to 180 in both triangles. So I could actually mark this one, but I don't need to. 2 angles are enough to say that these 2 triangles are similar by angle, angle. If their angles are the same, then they automatically are similar triangles. Side, side, side says that 2 triangles are similar when all 3 sets of corresponding sides are proportional. So here's an example of that. Okay. So we have this triangle, which is 2, 3, and 4. And we check to see 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. So we had the same scale factor, which means that all 3 sides are proportional. We don't have to know anything about the angles if we can confirm that all 3 sides have the same scale factor. Okay? If that's true, then they are similar triangles. And our last theorem is side, angle, side, which says that 2 triangles are similar when 2 sets of corresponding sides are proportional and their included angle is congruent. All right, so here's an example of side, angle, side. Notice it's called side, angle, side because if you read it in order of the triangle, it goes side, angle, side. This is what we call our included angle, right? So it's in between the 2 sides that we're looking at, right? And it has to be the same 2 sides and angle on both triangles. So we have corresponding sides, and then our included angle here is already marked as congruent. So we have this part of the definition. We just need to check, are the sides proportional? If I try to think of a scale factor, how do we get from 2 to 3 and 4 to 6? That was not as quick and easy as this one was, right? This was times 2. So again, just like in our last video, if you're not sure what the scale factor is, just divide them. 3 divided by 2, 6 divided by 4, and we'll see if they're the same number. So 3 divided by 2, 6 divided by 4. There are 2 ways you can do this. You can simplify each fraction, see if they simplify to the same, or you can use your calculator. I'm going to simplify it here. 3 over 2 is simplified. 6 over 4 can simplify by dividing top and bottom by 2. And that would get a 3 over 2. So notice we have the same number here. That means we have the same scale factor. So we have proportional sides, side angle side. We are good. We are similar triangles. Okay? So we're going to do 2 examples of each of these. Let's start with angle-angle similarity theorem. So you'll see me write it like this sometimes, angle-angle similarity. Right? Example 1, we have angle A is 21 degrees, angle B is 105 degrees. Angle E is 54 degrees, and angle F is 21 degrees. So I can automatically see we have one set of angles that are congruent. So I'm going to put my congruent mark on this angle and this angle. Okay? Now this is 105, this is 54. We know that those aren't the same, but we have a missing angle on each one. So we want to try to find that angle to see if we do have another set of matching angles. So like I said before, all 3 angles have to add up to 180 degrees. So if this is 21, this is 105, what would this third angle have to equal? If you're not sure, you can do 180 minus 21 minus 105, and when you do that, you will get 54. So this third angle has to be 54 degrees in order for it to be a triangle. So now that I've done that math, I can see, hey, we have another set of congruent angles, so I'm going to mark it with 2 marks. Okay? So doing our math told us we had 2 sets of congruent angles. It doesn't even matter what the third angle is, although if you calculated it, it would be 105. So we can write our similarity statement. A similarity statement is saying one triangle is similar to another, and it's matching up the corresponding points. Okay? So it doesn't matter how you write the first one. I'm going to say triangle A, B, C. All right? I just went in order. A, B, C. Now it does matter how you write the second one. Is similar, so I'm going to do my similarity symbol, to triangle. Okay, so now I need to see A matched up with F. So they need to go in the same order. So if A came first, F needs to come first too. B matched up with D, okay, and C matched up with E. So triangle ABC is similar to triangle FDE by angle-angle similarity. And that's how we write a similarity statement. So let's try example 2. I see one angle already marked as congruent, and I'll mark back on top of that. So angle T and angle M are already marked congruent. I need to find just one more set of congruent angles in order to say that they are similar. And I see a set right here, okay? So this angle here on the left of our N and on the right of our N, those are congruent. What type of angles are those? They are vertical angles. Just a reminder here. Vertical angles are angles that have already been proven to be congruent. They're vertical when they're facing each other. Sometimes they're called kissing angles, right? So we have 2 sets of congruent angles. Let's write our similarity statement. So triangle, and I'm going to say T in I. So T in I is similar. Oops, let's try that again. Similar to triangle. So again, match up your angles. T matches up with M, N to N, and then A to I. So M, N, A by angle-angle similarity. Okay. Let's look at side-side-side similarity. So in this case, we don't have any knowledge of our angles, and that's okay. We have all 3 sides available for us to check. We need to check to make sure all 3 sides are proportional, not congruent. So we're looking for a scale factor, or we're checking the ratios, whichever would be easier. Okay, in order to match up our sides, they need to be corresponding sides, which means our smallest side needs to go with our smallest side, and our largest side to our largest side. That's the easiest way to match them up correctly. All right, I'm just going to set up 3 fractions. That's how I like to do it. I set up 3 ratios. I simplify them to see if they're all the same number. So it doesn't matter what order you go in as long as you stay consistent. So I'm just going to go little to big, little to big, little to big. So that would be 10 over 15, 8 over 12, and 6 over 9. So now let's see how they simplify. What does 10 over 15 simplify to? That's 2/3, very good. Okay, 8 over 12, let's see, both of these were divisible by 5. Both of these are divisible by 4, so that would be 2 over 3. And both of these are divisible by 3, so that would be 2 over 3. Okay, so all 3 simplified to be the same number, which means we have the same scale factor, and that makes us proportional. So we can write our similarity statement. Triangle, and again, it doesn't matter the order. I'm just going to go in order A, B, C. Alphabetical order, I guess I should say. Is similar to triangle. So A was in between the largest and smallest side. So largest and smallest side gives us D. B was between the smallest and middle. So that would be E. And then F. Sometimes you can do it by the shape, but just be careful. Sometimes it'll look like you have it the right way, but if you aren't checking your numbers, you could flip-flop some letters, okay? And then say our theorem by side, side, side similarity. And there is our similarity statement. All right, our second example for this, we have all 3 sides again, so let's check them. Match up your largest to your largest and your smallest to your smallest. So which side would 15 match to? It would match to your 5, very good. So I'm going to do 15 over 5, okay? 6 over 4, and 18 over 6. So smallest, largest, middle. Now let's simplify each one. So that's going to be 15 over 5 is 3. 6 over 4, that one doesn't reduce to 3. That's 3 over 2. 18 over 6 is 3. So even though we had 2 sides that had the same ratio, we had one that did not. So these triangles are not similar. If that's the case, we cannot write a similarity statement. We write not similar. Okay? And our last 2 examples here. We've got side angle side, and we have example 5 and example 6. So let's look at this one. Let's first check to make sure it is side angle side. In order for it to be side angle side, our angle has to be directly between our 2 sides. So where our 2 sides meet is the angle that we have information on. Okay, so it looks like we do have side angle side. Our angles are already congruent. It says 50 degrees and 50 degrees. So we just need to check to see if our sides are proportional. So I'm going to match the largest to the largest and the smallest to the smallest. 12 over 8 and 24 over 16. So 12 over 8 would, let's see, both are divisible by 4. So that would be 3 over 2. 24 over 16, they're both divisible by 8, which would be 3 over 2. We have a congruent angle, and we have 2 proportional sides, so let's write our similarity statement. Triangle A, B, C is similar to triangle. What would the second part be? Okay, A matches up with, well, let's see, from A to B, I go across my smallest side. So I need to go across my smallest side, so that'll be D to F. So A is going to match with D. And then I'm at my angle 50, which is B, which should match with F. And then it goes to E. All right? And then by side angle side similarity. All right, our final example here. This is actually 2 triangles overlapping each other. So let's draw them separate. Sometimes I like to do that. It helps me see the problem better. So we have one triangle here like this, and that's A, E, B, with a 12 and a 9. And then we have another triangle here like this. That's A, oh goodness, stop that, C, and D. Let's see if I can make it stop. Okay. So if I want to calculate the side of AD, well, let's look here. A to E is 9, E to D is 3. So what is the full measure of A to D? Yeah, we have to add them together. 9 plus 3 would give us 12. All right, we can do the same thing on the other side. 12 plus 5 is 17. So it looks like, sorry about that, guys. It looks like there we go. It looks like we have side angle side. We have two sides, but what do we know about angle A? Is it congruent? Well, if we look at our picture, angle A overlaps with angle A exactly. So it's the same angle. So we can actually mark that as congruent. So our included angle is congruent. Now we just need to check our sides. So let's set up our ratios. Smallest side to smallest, largest to largest. So 9 to 12, and then 12 to 17. Let me do this in purple. So, are the two triangles similar? Let's check. 9 over 12 can reduce. They're both divisible by 3. That would be 3 over 4. 12 over 17, that cannot reduce. So 3 over 4 is not the same as 12 over 17, so we are not similar. And we are done.